In this video, we'll look at extended tile sequences and finding the intersection of graphs given the slopes and t-intercepts. Our question is to create an extended tile sequence C of n whose graph has slope -2 and t-intercept 3, and an extended tile sequence D of n whose graph has slope 3 and t-intercept -2, and give figure n for each sequence, and then use the two-column method to determine where C of n and D of n intersect, and finally graph both function graphs. In a previous homework video, 2.5.3, we found figure n for C of n as 3 black tiles and 2 opposite white end strips. In a similar way, we can create figure n for D of n by using the t-intercept for the constant term, so -2, so 2 red tiles, and then the slope as white end strips. So for m equals 3, this will be 3 white end strips. Now we'll set those two nth figures equal and correspondingly the function equations equal. Then to simplify, for the figures, we'll add 2 white end strips and 2 black tiles to each side, and symbolically we'll add 2n and 2 to each side. Then for the algebra pieces, we'll simplify by removing 0 pairs, and symbolically we'll simplify and we'll determine that 5 equals 5n. For the algebra pieces, we'll split each into 5 equally sized groups, and we see that n equals 1. Symbolically, we divide each side by 5, and we see that n equals 1. We have found that the nth figures of C of n and D of n have equal function values when n is 1. To find the point of intersection, we can evaluate either function at n equals 1. When we put 1 into C of 1, we find the function value to also be 1. So the two graphs should intersect at the point 1, 1. Now, using the t-intercepts and the point 1, 1, we can graph C of n and D of n together. Let's check. We found that C of 1 is 1, and to check, we'll evaluate D of n also at n equals 1. D of 1 is 3 times 1 minus 2. 3 minus 2 is 1, which checks. We can also see that our D of n figure n shows a t-intercept of -2, and because there are 3 white end strips, a slope of 3. So that also checks. Our answer is we have our two nth figures, we have our two graphs, and we see that the graphs intersect at the point 1, 1.